Hey guys, this is my new 3-node Proxmox cluster set up with high availability. And in this video, we're going to talk about how I got it set up. So if these boards look familiar, they probably should if you've watched this channel before. Those are Zimaboard 832s that were provided to me by Zimaboard months ago. I was going to make this video a long time ago and just never got around to it. So sorry to the folks at Zimaboard for taking so long to do this, but thanks for providing the hardware. I do appreciate that. So these are 832s. That means it's got 8 gigs of RAM and 32 gigs of storage. I do have a 1 terabyte SSD plugged into each one of them. There's some cables in the back where you can kind of see that plugged in. And then I've got a 64 gig USB drive as the boot. But with all of that said, let's jump over and take a look at the process of getting this set up so that we can then kind of go into what the next video in this little project might be.
This video is sponsored by Tuxedo Computers and the Tuxedo Aura 15 Gen 2. The Aura 15 Gen 2 comes with an AMD Ryzen 7 5700U. That gives you 8 cores and 16 threads while only sipping 15 watts of power. This means that the 49 watt-hour battery will get you hours of productivity while on the go. You'll also get the AMD Radeon RX Vega 8 featuring 8 GPU cores that clock up to 1900 megahertz. The Aura 15 Gen 2 supports up to 64 gigs of dual-channel DDR4 RAM. That way you can have as many Chrome tabs open as you need for your productivity. With a thickness of less than 2 centimeters and only weighing in at 1.65 kilograms, taking the Aura 15 Gen 2 will be a breeze. You'll get a 15.6-inch 1080p screen that covers 95% of the sRGB color space with a peak brightness of 300 nits. The Aura 15 Gen 2 comes loaded with I/O ports, including USB 3.2 Gen 2 Type-C full-feature DisplayPort 1.4, a USB 3.2 Gen 1 Type-A, 2 USB 2.0 Type-A ports, and an HDMI 1.4 port that includes HDCP, 4K UHD at 30 Hz native. You'll also get a gigabit LAN port and a 2-in-1 headphone microphone jack, as well as a micro SD card slot. For more information or to configure your own Aura 15 Gen 2, check out the link in the description. So once you've got your hardware sorted, of course, the next thing you want to do is get Proxmox installed on each of your individual nodes. So of course, you'll need to create a bootable USB using whatever means that you like to use to create your bootable USBs. And you need to boot from that bootable USB and start the installation process like we've done in previous videos. Of course, the first step will be to set up an email address and a password for your root account. Next, you'll give each of your different nodes a host name, an IP address, a gateway, and a DNS server so that it can communicate with the internet for updates, downloads, things like that. And then at that point, the installation process will proceed. And then after several minutes, depending on your hardware setup, you'll be brought to a login prompt. On that screen, you'll see the IP address and port that you'll need to go to in your browser so that you can log into your Proxmox server for the first time. And of course, you're going to do that for each of your individual nodes. So if you've got 3, you're going to do it 3 times. If you've got 5 times, whatever, right? So you're going to do this for each of the individual nodes that you're going to put on your cluster. Okay, so once you've got Proxmox installed on all 3 of your nodes, what you'll want to do is get logged into each one of them in separate tabs, and then jump over to node number 1. So here we are on node number 1, and we're on Data Center. That's where we want to start. Then what we want to do is come over here to where it says Cluster, click on Create Cluster, and then we're going to give it a cluster name. So I'm just going to be original, call it DB Cluster, like so. You've got the option to add additional network ports here, network connections, if you will. Basically, the lower the number, the more priority it will have, and then any additional network connections that you have there will be for failover in case something goes wrong, more bandwidth is needed, or something to that effect. So once we've got our cluster named and we've got our network, our cluster network set up here, what we can do is click on Create. We're going to go ahead and give this just a second here, and it says Task OK. So we're going to go ahead and close that right there, and then we're going to click here right on that cluster and click on Join Information. Here we've got an IP address, a fingerprint, and some join information. What we want to do is click on Copy Information, and then we want to jump over to node 2. So we're going to come over to here. Again, we're going to go to Data Center. We're going to go to Cluster. Then we're going to click on Join Cluster and paste that in there. It automatically filled everything out except for the root password of the first node. So we want to go ahead and put that in now, like so, and then click on Join DB Cluster. So now it says it's stopping the PVE cluster. At this point, this node has become kind of unresponsive, and that's fine. That's perfectly normal. What we can do, though, is jump over to back over to our first node, and here we can see that node 2 is joining. It's got a little question mark right there. And here in a moment, once it has done its thing, that will turn into a check mark like it's done there. And now we've joined the second node to the first node in our DB cluster. So let's jump over and do the same thing on the third node. So we'll jump over to here. We're going to click on cluster, join, paste, put in the root password. Again, that is the root password of the first node, not necessarily the root password of this node. Hopefully you're using different root passwords on all of your systems, but it's the root password for the first node, whichever one started the cluster. So once we've got that, again, we're going to go ahead and click on join the cluster. Again, it's doing the stopping the PVE cluster service. We jump back over to here. Now we can see cluster or DB cluster 03 set up and ready to go, or setting up there, and we'll be ready to go here in just a moment. So here we are just a moment later, and we can see that all three of the nodes are part of the cluster now, and we can actually administer each one of these nodes from each of the different dashboards. So if we jump over here on DB cluster 1, or if we come over here to DB cluster 2, just like that. And here, again, we've got cluster or DB cluster 1 and DB cluster 2. And again, DB cluster 3, we may have to log back in there, and that's fine. So basically my point is you could administer all three nodes from any of the three nodes. And I kind of dig that kind of flexibility in a setup like this. So there we go. Cluster 1, cluster 2, cluster 3, all three of them, again, access to all three of the nodes on the cluster. So now that we have our cluster set up, we want to set up storage for each of the three nodes so we can have high availability and replication. So let's jump back over to node 1 and start getting our storage set up. So here we are back on node number 1. While we're here though, just real quick, we can kind of take a look at this dashboard and see that our status is good. We've got 3 nodes online, 0 offline. Below that, we've got the combined resources of all of the nodes in our cluster. So we've got 12 CPU cores, that's 4 nodes, or 4 cores per node. We've got about 23-ish gigs of RAM available. Of course, that's 8 gigs per node. And then for storage, we've got 121 gigs available, but that's because we haven't actually configured all of our storage. That's just the storage that's available based on our boot drives at this point. And on the right side, we can see the individual nodes, and above that, we can see our guest services, or whatever you want to call it, where we're going to have containers and virtual machines. It'll show us what's up, what's down, that sort of thing. So now let's jump over to our first node here. We're going to come down to where it says disks. And right here we can see we've got 2 separate disks. We have a dev SDA and dev SDB. The SDB is the USB drive that we're booting from. That's got our operating system. And the SDA is the 1 terabyte SSD that we're going to use for our storage. Now, if this says usage, yes, GPT, yes, you may have to go in and wipe the drive in order to use it here. But mine is a fresh drive, so we're good to go. So what I can do is just come down here and click on ZFS, click on Create ZFS. We're going to give this a name. We need to make sure that whatever name we give this particular storage pool, the ZFS, that we give it the exact same name on all 3 nodes, so that when containers and VMs are moved from one node to another, their storage is the same. The name of the storage is the same, so that they can identify where they need to be at any given time. So we're just going to call this storage. And the reason I'm deliberately naming this storage is because I plan on making another video where I'm going to take an existing Proxmox server that's got multiple containers on it and moving all of those containers over to this 3-node cluster. So if you're interested in that, let me know in the comment section. Hit the thumbs up button. Don't forget to subscribe if you haven't already. But basically, now we've got our storage name here. I'm only using 1 disk per node. However, if you had multiple disks, you could set up RAID this way. Again, I'm just going to use the single disk setup here. I want to make sure that add storage is checked in this little box right there, but only on the first node. When we get into nodes 2 and 3, or further than that, if we wanted to go that far, we're only going to have the add storage checked on the first node. That's very important. So we're going to come down here. We're going to check the box next to all of the different storage devices that we want to use. Again, I've just got the one, so I'm going to click Create. We're going to give this just a second to do its thing here. There we go. Now we've got storage set up. And right here, again, we've got that question mark, meaning that it is currently setting up in the background. So while it's doing that, we can jump over to node 2 and do almost the exact same thing. So we're going to come over to node 2. We're going to go to, again, we're going to check our disk, make sure that it is available right here. Again, we've got SDA and SDB. We're only interested in SDA here. Again, this one's clean. It's ready to go. So we can come down and click on ZFS. Next, we're going to click Create ZFS. Again, we're going to call this Storage. Again, single disk, that's what I'm using here. I am going to uncheck that Add Storage, like I mentioned just a moment ago, and I'm going to check the box for the device that I want to use for this storage. We'll click Create. And then once that is done, we're going to go over to node number 3, do the exact same thing. Disks, this looks good. ZFS, Create ZFS, Storage, single disk, Add Storage is off. SDA is on, and click Create. So at this point, we've got Proxmox installed on all of our nodes. We've created a cluster and we've joined all of our nodes to that cluster. And we've got our storage set up for each of the different nodes. So the next thing we want to do to get replication and high availability set up is actually create a virtual machine or a container. I'm going to do a container, but we need to do that next so we can move on to the actual replication and high availability section here. So what I'm going to do is I'm just going to come over here to my first node. I'm going to go to shell. I'm going to do a PVEAM update. We'll do PVEAM available. And then we're just going to go find one of these that we're going to use later. I always like to download Debian 11 standard like so. We're going to copy that. And then we'll scroll back down. So now what we're going to do is type in PVEAM just like we did before. We're going to say download. Local, because we want to use the local storage that's on the actual device. And then we're going to put in the name of whichever container that we just download, or that we want to download rather. So we're going to go ahead and just paste that in like so, and I'm just going to hit enter. We're going to give this a second to download and save where it needs to save. There we go. Now we have a container available that we can deploy. So let's go ahead and do that now. What we're going to do is come up to the top right, click on Create Container. The node will be on cluster number 1. We can, of course, change that right here if we want to, but I'm just going to put it on 1. The container ID is fine. We're going to call this first demo. Just for the host name, it doesn't really matter. Of course, this is just for demonstrative purposes here, but now I want to give it a root password. And once we've entered that twice, we can move on to the next step and click on Template. We can select the template we just downloaded. We can go to disks, and for this we're just going to select storage because that's the storage pool that we just created. We want to select a disk size. 8 gigs is probably fine. It depends on what you're doing, but I'm going to call it 16 just because. For our CPU, we're going to give it 1 core. For memory, I'm going to give it 512 megs, but I'm going to give it a gig of swap, just so I can type in something here. For our network, I'm going to come over to here. I'm going to make this DHCP for right now. For DNS, I'm going to put in some DNS like so. That way we've got DNS that isn't confined to our local network. And then I'm going to click confirm, and I'm going to say start after created, and then I'll click finish. So once this container is up and running, then we can move on to replication and high availability. Okay, so here we've got our task okay. That means we're good to go. So I'm going to go ahead and close this. And then right here we can see first demo is up and running. Just for the sake of it, let's do one more just so we've got some more stuff to play with here.
A few moments later.
Okay, so at this point we can see that we have 2 different containers up and running in node 1. So now let's go ahead and get replication configured. So what we're going to do is click on our first container here, and then what we'll do is come over to replication. We're going to click add, and then we're going to target one of the other nodes. At this point, it doesn't really matter which one you target because we're going to target all of them through multiple steps here. But basically we're saying, hey, container number 100, we're going to target cluster node number 2. And by default, it's just going to do this every 15 minutes, kind of synchronize the nodes to make sure that everything is current and up to date. You can rate limit this if you want to. You can leave a comment and have it enabled. Once you're happy with this, click create. And then we're going to do this one more time, like I mentioned. This time, though, we're going to go over to cluster number 3, and we're going to leave all of this the same and click on Create. Then we can come up, we can click our first option here, our first target, and click on Schedule Now. And then we can click our second target and click Schedule Now. And here over on the right where it says Next Sync is pending, we're going to give this a minute to do its thing, and then it will let us know when it's done and ready to go. Okay, so both of these now say status okay, how long it took to do it, when its next sync is, and how often it's scheduled, again, 15 minutes. So now that we've got our first container done, now we need to move over and do the second container that we've got here, this number 101. So we're going to follow the same steps. We're going to click our container or our virtual machine, whichever you happen to be running. We'll click add. Again, we're going to do DB cluster 2. We're going to leave everything else here the same because it's fairly standard good stuff. We'll click create. And then we'll do the same thing here. And we're going to come down here and do cluster number 3, create. And then again, we can schedule now on both of those. And over here, again, it says pending. We're going to go ahead and give that just a minute to do its thing. And then once this is done, we can move on to high availability. Okay, so now both of these have a status of okay. We can send when the next sync is, how long it was, and again, how often it's scheduled. Now, if we want to make sure that that's actually worked, what we can do is come over here to our storage on all of these nodes, really, and we can see a subvolume 100 disk 0, subvolume 101 disk 0. If we come over to cluster number 2, again, same thing. Cluster number 3, same thing. That tells us that our synchronization, our replication has worked. So now we can actually move into the high availability part of this. So to do that, what we're going to do is come over to Data Center. We're going to click on HA right here. And then what we want to do, up at the top it says quorum okay. That means that everybody's happy with how things are progressing. All of the nodes are working together. So what we want to do is add some resources. And what I mean by resources, rather, what they mean by resources are the virtual machines and containers that we want to monitor for high availability. So what we'll do is click on Add. We're going to click on First Demo here. All of this stuff in here you can just leave as it is. And then we'll click Add. We'll do the same thing. Oops. Right here, and we'll do second demo and click add. And now that we've got our two resources or our containers, VMs, those are pretty synonymous right now. Up at the top, we can still see our quorum is okay, but now that we can see DB cluster 01 is our master, but all 3 nodes are currently active. Okay, so now at this point, we should be good to go. But let's make sure that we are actually good to go by shutting down our first node. Now, before we do that, what I want to do is come over here to our first demo container here. I actually want to go to console and we're going to logged in, and I want to get the IP address of that node or that container. That container, and it's going to be 192.168.0.40. So what I'm going to do is I'm going to do ping. Oops. 192.168.0.40. I want to make sure that it gives me an IPv4 address. That's what the -4 is for. And then -T will just keep it going until I tell it to stop. So I'm going to go ahead and do that. And then what I'm going to do is come over here to my Omada controller. We can see that we've got a time of less than 1 millisecond here. So I'm going to come over to my Omada controller. And right here, I can see Proxmox node 3, 2, and 1. What I want to do is actually shut off node 1. So what I'm going to do is come over here to devices. I'm going to go to my 24 port switch. I'm going to click on ports. I'm going to come over to over here. Oops, that's too far. And cluster number 1 is on port 16. So what I want to do is check or click that box. Profile is going to be disable, and I'm going to click apply. Then I can come over. Let's go to node 2 because node 1 is going to become non-responsive. So let's open this back up. And all of a sudden, our request has timed out. So at this point, we can just kind of hang out and wait. What I want to do, though, is toggle both of these open and bring this back over so that we can kind of see in real time. I'm going to speed ramp this, but we can see in real time how these containers move from node 1 to possibly node 2 or node 2 and 3 or just 3. We'll let the system decide what it wants to do here. Okay, so here we are just a couple of minutes later. That does take a little bit of time. And of course, the more nodes you have, the longer it may take, depending on your network throughput and what kind of a connection you've got, those sorts of things. You could actually reduce the amount of time, the amount of downtime when there's an outage like this. If you had a Ceph server set up that was kind of a shared storage solution between the 3, rather than having individual storage nodes or storage pools on each one that are somewhat shared and synchronized, but a Ceph solution would actually be a better way to have a smaller amount of downtime in the case of a node going down. So here you can see that it actually did separate them out by going to the first demo went to cluster number 2, or the node. It says cluster here. I really should have named it something else. But then second demo went to node number 3, and of course I can come right back over to here and I can turn that port back on, like so. Now, ultimately, that doesn't do anything for us other than just turn the network port back on. It's not going to automatically move those containers or VMs back over to that original node. It's just now that node is available for if more resources are needed by those nodes or another node goes down. Now that node is back and available for use in that cluster again. So there you go. There's how to set up a basic high availability Proxmox cluster using 3 nodes. Hopefully you found the video helpful. If you did, do me a favor, give the video a thumbs up. Maybe consider subscribing if you haven't already. Also, I've been putting this out in my videos here lately. If you're interested in supporting the channel and getting something in return, which means videos with no ads, that's no baked-in ads, that's no YouTube ads, just straight to the content, you can join my Patreon, my dbtech.fans website, or become a member here on YouTube. However, if you join on Patreon or dbtech.fans, you can get ad-free content for just $1 a month if you want to go that route. So, but with that said, I do want to go ahead and wrap this up. I want to thank you for spending a few minutes of your day with me today, and I will talk to you in the next video.